Hello.
Hello. Hmm.
Did you manage to stop Cozystack from specific branch?
No, but I found the, what do you call it? I found in the CI logs the right reference to the platform OCI repository and everything else. So that worked out. Um, is my screen sharing okay?
Yeah. I think
Okay,
it
good.
is, the text is too small, but it is okay.
Yeah, we don't need the text that much. I think you can see everything in the terminal, yeah?
Yep.
Okay, good.
Hi guys.
Hello.
Hello guys.
Hello. I'll just post standard message that we are starting. Maybe somebody else will join. Oh, there were no announcements about our meeting on our Slack channel. It's a shame.
Oh, in fact, yes, it's my bad.
All right, let's wait for a few more minutes. I'll post a link to Zoom chat. Feel free to add yourself in attendees list. To have the opportunity editing this document, you can join Google group under this link and you'll get edit access automatically. And let's have a start. So welcome everyone in our bi-weekly community meeting. Please join our communities. We have community in Telegram and we have community in Slack, in official Kubernetes Slack. We probably don't have anyone new on this call, or is it? If there anybody new on this call who would like to introduce yourself and put few words about themselves, it's a good time to do that right now. All right, let's switch to our agenda. So the first thing I would like to introduce that we have written a really cool article about all the changes in past 2 releases. So for the last 2 weeks, we already had time to release 1.0 and 1.1, and also 1.2 is upcoming. I think we will cut it out soon. So the main thing of this release is moving to package-based system. And also we updated documentation. So for now, Cozystack supports 2 different modes for to be deployed. So the first mode is as it was before, like you just deploy a ready-made platform, and the second one allowing you to create your own platform. So for this, we have specific tool which is called Cozy Package, and it allows you to cherry pick specific packages from Cozystack and actually resolve the dependencies. There were also a few more changes added. So in 1.1, we added OpenBow and also renamed few applications. We get removed the virtual machine. Now it is 2 separate entities, virtual machine instance and VM disk, out of which you can prepare your own image, your own virtual machine. So it can use multiple disks. It can be ISO or normal disks. So for example, you can install Windows using that. We had also another entity which would allow you to run virtual machine with simple interface, but it actually was repeating functionality of this one. So we decided to keep only one image for this. And this one also supports connecting to VPCs. And also we added Quadrant, which is commonly used for AI-based environments. Also, one biggest change we have introduced is read-write many support. If you're using storage based on LinStore, you can now order RVX volumes from your tenant Kubernetes clusters. There were more things to talk about. Please feel free to check our blog post. It describes all of them. The second topic is migration to Gateway API. I'm not sure if somebody can introduce it. Maybe Kirill, you? Oh, okay. We don't have Kirill here. So in fact, there is a new pull request created. We are going to get rid of Nginx Ingress controller and migrate to Gateway API. For now, this pull request is made by Kirill. We need to review it, and please feel free to suggest other topics, some suggestions to code base. You can check it out here. And do you have any ideas about Gateway API support? Because we decided to choose Cilium Envoy Gateway. Maybe you have other opinion about the default choice for the users. If there is no other comments, let's switch to the other topic.
Well, Andrei,
Yeah.
What is your default choice?
Yeah, for now we are going to install it by default. I'm not sure if it is supported to switch to another one, but we need to choose some default technology which will propagate to our users.
And now, which Gateway API controller are you use?
This pull request actually adds user-faced application support, user-faced changes to the existing applications to use Gateway API. I think that also should support other Gateway APIs. That would be nice to make it vendor neutral, but we also need to add end-to-end tests and choose some technology which will be used by default. So for now, we decided to enable Cilium Envoy Gateway, which is integrated to Cilium, and update all our applications to use Gateway API instead of Ingress.
Yes, so definitely. So we would need to be flexible here. So it would be great if so if it was easy to choose other one. So I believe it's So from the platform side, it's easy to create a gateway object or an HTTP route or whatever, but to allow cluster admin to choose which implementation to use. So some use hub proxy, some use Nginx, some use Kong. Yeah, so around so many flavors, needs, whatever. So please don't hard code one option.
Yeah, it should be customizable, I think.
All right, then I think we will work it out. For now, we have the same logic with Kubernetes services. So we can publish them either using MetalLB or Cilium. We just described the specific technology which we commonly use for this. So for now, we use MetalLB, and I think gateway API objects quite similar to that because they use common API. There is also a questions about should we use the single gateway API or multiple instances like we did before with an ingress. So for now, we are still considering, and this PR is more likely draft. If you have some thoughts, please post them there. All right, then let's switch to the next topic. We have demo prepared for scheduling class. I'm giving my mic to you, Timothy.
Thank you. I might, yeah. Let me start sharing the screen. Okay. Do you see all of my screen or just
I think
part of it?
that's just part of this.
Just part.
Let me try sharing the entire screen then, just for a moment. Yeah, now I think it's good. Okay, so this demo is about the new scheduling classes feature. So the point of this feature is to allow the cluster administrator to configure the behavior of the pod scheduler in Cozystack. So that maybe one tenant should only be scheduled in a single data center, or maybe like some other tenant should have the option of being scheduled across different availability zones. And this is something that cluster administrators want to control without excessive configuration. So right now, it's not yet released. All the features have already been merged into the main branch, but it hasn't been released. I think it will be out in Cozystack 1.2. So the documentation is not yet live, but that's the preview of the documentation. And I think it's easier if I just start showing you how it works. So what this new feature introduces is a new custom resource called SchedulingClass. And it has rather familiar terms such as node selectors. It's a lot like the affinity terms that you would set up on any pod. So for this demo, we're going to create 4 scheduling classes. One of them will schedule every single pod on a given node, on just one specific node, node 2 in this case. And then another scheduling class will automatically set pod anti-affinity to all workloads that are created. So that means that for every workload, there will be only one pod from that workload per node. So if you've got like a 3-pod Redis cluster, there will never be 2 the two pods of that Redis on the same node. And then there you can also use topology spread constraints because the previous scheduling class is not too useful. What if you have just a few nodes but very many pods? So we create that. And then just for the sake of demonstration, scheduling class that locates all the pods of one application on the same node. Okay, so these are the scheduling classes. They have some representation in the dashboard. So if you, as an administrator, are creating a new tenant, so in the dashboard, you now have a dropdown called scheduling class. And when you open the dropdown, it shows you all the available scheduling classes. This will be the scheduling class applied for the tenant. And of course, you can leave it empty, then the default Kubernetes scheduler will work and no special no special scheduling rules will apply. So let's create 4 tenants for each of the 4 scheduling classes. So as you can see, in the spec of the tenant, we specify the name of the scheduling class that we want to use. So that's the collocate one, the one per node one, the one that uses topology spread constraints to spread the pods evenly, and the special one that schedules all pods only on node 2. So they're being provisioned right now. Let me check if they're all ready. Okay, good. So now we can start firing up some pods and seeing what happens. So first, we're going to run a demo for the collocate scheduling class. We're going to create a small Redis cluster. And so as you can see right here, all of the 4 pods, these are 3 Redis Sentinel pods and 1 Redis pod itself. They're all being scheduled on node 0. So if we continue, and we're going to scale up the Redis to 9 replicas. And again, as you can see, every single pod is getting scheduled to node 0. So now let's create a second Redis, again in the same tenant, also in collocate. The point of this is to show that different applications are independent of one another. So we're gonna look and see what happens, because this is a matter of chance. I had a few test runs where they would all go to node 0 regardless, but hopefully not. Let's see what happens here. And yeah, so this time we got lucky. Yes, all the pods of the first Redis are node 0, but the Redis that we just created, the second one, all of its pods are node 1. So let's clean this tenant up and move on to the next scheduling class. Okay, so the next one shows where the scheduling class where we got hard anti-affinity for the pods. So in fact, in our Redis application, we've got the Redis Sentinels hard-coded to 3 replicas. So we have to patch the Redis failover on the fly, otherwise it will not fit into the cluster. And so now, as you can see, we've got 3 pods of this application, and they're all on separate nodes. If we try to scale up the Redis to 3 replicas, we'll get 2 more pods trying to be scheduled, but that will not work, as you'll see in a moment. So as you can see, the second and third replicas, they have no node, they have no nominated node, and they're in a pending state. And so if we run the scribe on any one of them, you can see that the Cozystack scheduler, note that this is not the default kube scheduler, it's the Cozystack scheduler. It's complaining that there is no nodes available for these extra pods. And again, the scheduling is independent between applications. So in the same tenant, we can create another Redis cluster. And you'll be able to see that despite the first Redis occupying all 3 of the nodes, a second Redis cluster is independent of the first Redis cluster, and it will also be able to get scheduled. So yeah, we can see the Redis demo, the one where we've got the 2 pods in independent state. But then we can see the Redis demo 2, and it is also scheduled just fine. You can see it's sharing a node with the Sentinel pod from the first Redis, so that's no problem. The pod anti-affinity only works between pods of the same application. So yeah, let's clean this up. As you understand, having this hard anti-affinity is not too useful. So since about Kubernetes 1.25, we've got the topology thread constraints feature, which lets us schedule pods a bit more intelligently. So let's go. Now we're scheduling Redis in the tenant spread namespace, which has the scheduling class with topology spread constraints. And as you can see, yeah, they're approximately evenly spread out. There's 2 pods on node 1 and 1 pod on node 0 and node 2. So next, if we scale this application up all the way to 9 storage replicas. So this takes a little while. And yeah, you can. So the script counts that they're evenly distributed. You can look yourself. Node 1, 0, 2, 1, 2, 1, 0, 0, 2, 0, 2, 1, 1, 2. So apparently the topology spread constraint works. And so finally, we'll clean this up, and the final demo is when all the pods are allocated to node 2. Okay, so they're all terminating, and now let's go to the final tenant namespace where we've got the node selector for node 2. And of course, there is no tricky automation logic here. They're just having a node selector applied to them. And now we'll see, yeah, all the pods are scheduled on node 2. And if we create another Redis cluster, it also will go to node 2 because we're not talking about inter-application affinity or something like that. That's just a simple dumb node selector. Yeah, and this is it. So the rest is just cleaning up. And so basically, what this feature is, you may have heard of the global topology spread constraints that you can configure for the Kubernetes scheduler. What this feature lets you do is configure these things as cluster scoped resources and apply them to specific namespaces. Yeah, I see there's some questions.
Thank you for amazing demo, Timofey. What if pod already have some affinity?
So if the pod already has some affinity, the affinity terms will be merged.
Okay. And is it possible to specify soft affinity that way?
Actually, I haven't tested this, but yes, it should be possible to specify. You should be able to specify soft affinity. There is just a couple of things. I haven't really tested that, and I haven't tested how soft affinity rules interact with existing soft affinity rules. So maybe they may not be merging correctly, so that might be an issue to fix if it comes up.
Thank you. We have a question from Raslav.
Yeah. Hi. So that's a great feature, and I love it. So currently, I do this in very other way, in more ugly way. I'd say. So a question: how will this work for other objects that are not pods? For example, if we have a 10 node cluster and create a finally, I would like a workload to run only on nodes with some label, but we do need a VM disk to be created on that local storage. So VM disk. So when you create a VM disk on storage class local, it will create on any node that can basically create it.
Yeah, I understand. Well, the way this thing I showed you is implemented, it is just a fork of the kube
For pods.
scheduler that merges affinity terms in memory. It takes the affinity terms that you have on a pod, and it merges them with the affinity terms that it takes from the scheduling class. And so the kube scheduler, it only works with pods. So I don't think I'm not sure what the ordering would be when you're creating VM disks. Most likely, there's usually a pod that comes first, and then a persistent volume is provisioned. But
Waits for first consumer.
Yeah. If it waits for the first consumer, then yeah, the first consumer will get scheduled according to the scheduling class, and then it will get provisioned, and you're fine.
And Miroslav, do you solve that somehow different way right now? Can you tell a little bit more about that?
So currently I add annotation to the namespace to specify node selector, basically, so in the namespace, but it works only for pods or VMs itself, so it doesn't work for VM disks. So it should work, but for, when I create VM disk, so as I understand, it creates some pod to create a VM disk or whatever, but it doesn't really work.
That's a very interesting case. I think we'll check that. Thank you for
But by the
pointing
way,
this out.
if there's a pod being created to create the VM disk, that same
I don't
pod
know.
is
I don't know.
subject to the same constraints, unless of
It
course
should be, but
that pod lives in a different namespace.
yeah, it should be, but currently, so it doesn't go to the nodes I would like this to be created. So when this feature will be created, in which release?
1.2 certainly.
1.2. Okay.
Yeah.
Thank you.
Talk quite soon. And is scheduling class is cluster-wide object, like a
Yes, it
storage
is.
class?
Yes.
That might be an interesting option to also. Not sure how it should work, but I think that storage class also should support some scheduling. Maybe I'm wrong. So that might be interesting also to extend the storage class with a specific annotation or parameter, because it allows you to extend the storage class object with specific parameters. The only thing I think they are all not objects, they are key value, which are strings. But I think that we can point specific storage classes to the scheduling class in this way. But that also makes a difficult logic to integration with all existing storage providers. Yeah, that's an interesting question. We have to take a look at that.
Thank you.
Nikita has a question.
Yes, I was thinking about some kind of a safeguard, because if you specify an incorrect affinity, for example, a required affinity that bound pod to a node, and if you have one replica, the affinity will prevent this pod from updating with the rolling update strategy. And I can imagine of some corner cases that could happen with those automatic specifying affinities and topology path constraints. So my question is, are there any safeguards? Do you check something like replica count or something like that?
No, there is no more safeguards than there is in vanilla Kubernetes. Just like in vanilla, you can put some bad affinity terms into a deployment, and you'll get garbage on that as the outcome.
Yes, I was thinking about that, but it kind of differs when it's specified manually and when it is specified automatically. So it can sometimes act unexpectedly. But okay, I see.
Yeah, this is
Absolutely,
also
yeah, and
another. Yeah, please
this
go
is
ahead.
another reason why this is a cluster scoped a resource which is only available to cluster admins.
We were also thinking about how can we implement the more reliable errors for the users in that case. Just for example, if they creating pods, they get deployed the application, the pods are created, but they don't see any errors if those pods can't be scheduled just because of insufficient quota or wrong the scheduling class. So
Absolutely, yeah. And this scheduling class is yet another foot gun to be aware of. But I think that is a systemic problem that we have to solve in the future anyway.
do you have any ideas how can we simply solve that? Because I have only bad ideas like render Helm before it get applied and try it out. But I think that also will not cover all the cases.
Well, since specifically for the scheduling classes, because we have control of the scheduling component, the Cozystack scheduler, we could actually teach it to write error messages, not just as pod events, but maybe also as the parent Helm release event, something like that.
Yeah, that sounds good. So we can extend our application object with new condition, just for example, and if it see that some pods are not scheduled by the specific label selector, it could write that this application can't be scheduled.
Yeah,
Maybe
something like.
maybe a dashboard could read resource status and just report if pods of those or volumes
Absolutely,
are in pending
absolutely.
state.
The dashboard can read the status of the Helm release. I unfortunately already cleaned up everything, so I can't show you. But in the dashboard, you can, let me show you a different Helm release. And I've deleted everything else. I'm sorry. But
I think
yeah,
you can
but the
check some modules.
Yes, you're right. If I go into modules and I don't know, open the ingress module, see it has the conditions, and these conditions are just copied from the Helm release conditions. So we can teach the Cozystack scheduler to report the condition that it cannot schedule a pod all the way up to the parent Helm release. That would be possible.
That sounds really cool and easy to implement. What do you think? Is it possible to add another type of condition into Helm chart, or it is possible to store it in some other object?
Sounds like implementation details that will need a little bit of research, but it doesn't sound difficult now.
Yeah, I was just thinking about that case that Cilium actually writes extra condition into node object. So it might be common pattern for extending already existing conditions for Helm charts with our own conditions. So we don't need to think about the new storage.
Yeah. So there's one thing that is conditions, and another thing is events.
Yeah, events also very important thing. So we can add additional page which will describe the events. And we probably can do that already soon because we already have events for Helm releases.
Yeah.
So we can track. Yeah, cool idea. Thank you. We also have two topics to discuss. Not sure who have written that.
Sorry, Andrei, I cannot find the reins. And thanks, Timofey, for presentation. I would like to just ask whether I understand correctly. So via this scheduling class, you can just assign some certain scheduler for the tenants. That means you can specify which nodes this tenant will be run. Yes.
For instance, yes.
Yeah. Okay.
Yeah, for now, actually, we have a user story. They have two data centrums. They want to schedule pods in specific data centrum for all of them, for all tenants by default. And for the users who actually paid for second data centrum, for replica in second data centrum, they want to have the opportunity to schedule pods on both of them. That's actually a solution for this use case.
Yeah, that's use cases also that you can a little bit more splitting or organize your tenant clusters to predictable way, I would like to say. Can I use it also, for example, if I will run link store on certain nodes and is in a tenant, and then I will assign if they will have more storage, and then I assign the whole cluster will be running on this.
For now, LinStore actually works slightly different way. First, we're trying to use wait for first consumer storage classes. That means that PVC is getting provisioned after the pod gets scheduled. So that's
Andrei, I think the question is a bit different. Robert, the issue is that LinStore has a lot of its own configuration settings, and maybe it's not the best idea to apply the custom scheduler to LinStore pods.
Okay.
Although you can certainly do so if you add the correct annotation to any pod, the custom scheduler will work with it.
Okay. And is there any guarantee that no other task will be scheduled on these nodes?
No.
No, yeah, I don't think so.
So if I will do not specify the custom class, the Kubernetes itself can assign some workloads on these nodes anyway. Okay.
Yes.
Okay, understand. Okay. Thanks.
That might be also interesting to consider moving this option to each application itself, as we do with storage class right now, or moving storage class on the tenant configuration level. Let's just have a think about that.
Thanks. It seems to be quite nice feature. Anyway.
Thank you. So we have two topics to discuss left. The setting daily connection limit. Not sure who actually put it. Is there anybody else who actually put this topic into the discussion list?
It was me, but Kirill mentioned it in our Slack channel. Maybe.
All right. Let's move it to the next community call then. And the second one is Club Helm Haters. I like the subject.
Dumb Helm.
Let's throw out Helm and replace it with something else. I guess that was the question.
Yes, we can choose Microsoft Word, for example, or something like that.
I'm not sure about the Microsoft Word, but I have other topics to discuss. I think that we really want to have the opportunity for provide to the users the easy way to spawn their own applications. So for now, the users only have the opportunity to create applications using kubectl. I think we have to create a CLI tool. I already have, I think I already demonstrated in previous call. Cozystack, which actually allows you to create virtual machines, simply access them through the VNC, runs ordinary tasks like port forward and migrate the virtual machine itself. I still not sure about the interface, how it should look like. Anyway, if anybody interested to practice with your AI agents, please feel free to take this amazing task and implement something for Cozystack. I think that might be easily implemented. You can use this pull request as base. So in fact, when we have already made CLI tool, that also should be easy to connect it to your own AI agents. So you can actually write, hey, I want a Postgres cluster with 3 replicas and this amount of this resource preset, and it will actually use Cozystack to create Postgres cluster. So I think that might be a big epic for extending Cozystack API with more user-friendly CLI interface. And of course, for now, we have so many things which are confusing our users. For example, if you create virtual machine, you need to know about all the objects under it, under the hood. For example, and users who are not aware of Kubernetes too much, they might be confusing because normally they work with one entity under apps Cozystack AI, IO, and in fact, under the hood, the other entities created other virtual machine entity and virtual machine instance for KubeVirt API. So I think this tool can actually also cover the simplicity and deliver simplicity for our CLI users. All right, then we probably don't have other topics to discuss. We had some pull requests which are taking attention.
By the way, Andrei, I figured out what the daily connection limit is about.
Yeah.
I think Kirill meant if it's a good idea to set the keycloak session length to 24 hours.
Not sure. I'm actually not very aware of this subject. Not
Yes,
sure if I can.
neither am I. It was a recent fix because it was annoying that we would get logged out of the dashboard very frequently. I even
All
think
right, got it.
one of our clients came complaining, so we did that.
That might be. Is there any other correct way to solve that? I think the dashboard itself should update the token, but dashboard is covered under OEDC proxy.
So the OIDC proxy, the OAuth proxy should actually work fine with the refresh tokens and everything else. So I don't know. I think right now it's quite fine as it is.
Right. Interesting case, actually. I'm not very aware of this subject. We've got 2 requests. So I think, Miroslav, is it you? Yeah.
Yes, right. Yeah.
Could you tell a little bit more about that?
Yeah, so basically, the documentation in version 1.0 is a little incorrect. First, you cannot patch. So when you patch the object, so it will not create a child structures if bundles. So, for example, if bundles is not there, you can create enable packages and put object inside. So it's about number 1. And number 2 is when you actually add this manually or whatever way. So in my case, it didn't really add the package, so I had to manually run Cozy pkg add blah blah package.
All right, got it. I think that we don't have NFS server in our as an option to our bundle. I'll take a look at this. Thank you for the report. And the other issue is probably the rest are created by us, or there is also a problem that tenants nested more than 1 level deep cannot access services of the root tenant. The root ingress controller. Yeah, this is known issue. We probably need to think about some trigger which would allow you to enable this mode, but that might be really difficult to control and cover all the cases. This is actually done by design, and also I'll assign it to me and I'll answer this question later. Right then, do we have any other questions?
Yes, I have a question to you, Andrei. So I have noticed that your hair had updated. Is it related to version 1 release? So kind
No,
of
unfortunately.
new hair, new release, and so on.
I lose in poker.
Awesome.
By the way, we are going CloudFest next week. If you're interested, feel free to join. If you're interested in getting free ticket, please PM me and I'll provide you promo code from our company. And also we will have Timur at community table in Amsterdam, I think, for KubeCon. So you have a chance to meet Timur in a while. So in this way, I would like to say thank you and see you in 2 weeks, same time.
I cross fingers on the KubeCon success.
Thank you.
Yeah, sure.
Bye-bye.
Hello.
Oh, yeah. You have a question?
Yeah, sorry. So the question is not related to today's topic, May I ask it or not really?
Yes.
So playing with getting this for the MSP for basically for service provider. So how to use VLANs that are currently in the infrastructure that are provided by Switch and put VMs to that VLAN?
Originally, we solved that by delivering those VLANs to the nodes themselves, and then we use MetalLB to allocate IP addresses from those VLANs, and that works.
And what is the document? Where can I find this in the
I think this is
documentation or
not
somewhere?
documented yet, but you can write, you can read MetalLB. I think that the very first article in our blog post that was created even before Cozystack started existing. I'll provide it here. So the main thing is that you need to deliver the VLANs somehow in your physical nodes, and then you can configure source-based routing to route the traffic specifically for specific IP addresses. Please write me in PM. I'll provide you more details on that.
Yeah. So will that be really L2 connection or will it be L3 connection?
That should be mixed. First, you deliver the traffic to the node itself, and then it just use BPF for copying traffic on specific port.
So I mean, while I'm migrating from current infrastructure to Cozy, would need to allow some VMs to still run on old stuff and move VMs one by one to Cozy. To do this, we do really need some L2 connectivity to existed VLAN. So we cannot route entire VLAN to Cozy.
That's an interesting topic. We actually have no solution for that yet. There should be option to create VPC and route traffic. But for now it is not connected. For now it is not connected to any external VLAN. I think we need to check it out, and for now we have no solution for that. So there are all cases which we usually cover by delivering traffic to the node itself, and then pass it through to the virtual machine. We have this opportunity to create one-to-one NAT, so all the features, including ICMP, actually works. But if you want to see specific IP address, external IP address or internal one for your virtual machine, for now we have no solution for that. There should be an opportunity to do that in kubeOVN, but we're trying to not tie to the specific technologies very hard. So that might be interesting topic to research and see how it can be done.
All right, thank you.
Yes, I think you can create a VPC actually, and then you can just bring your VLAN to your node and somehow plug your VLAN interface from the node to a virtual switch, which is how in kubeOVN VPC is represented. So just
but we don't have interface for that, is it?
Yes, there are no interfaces for that, and I even think that kubeOVN could not allow you to do that. So, but it is technically possible, but I am not sure how.
Yeah, that's a task which needs more deeper research.
All right, thank you.
Thank you too.
Andrei, by the way, I wanted to ask how it's solved when you have a high availability cluster, how the master is solved the availability of the virtual IP address, I think, or
Not sure about the question. What do you mean by availability class?
with the Metal LB, you are controlling the traffic to the cluster, but not to services or to. But how do you control the high availability, the masters itself?
Actually, MetalB has its own the high available settings. It actually creates member list, if I remember correct. So it does the health checks even without accessing Kubernetes API. So in case, and in many cases, we use external traffic policy local. So it usually creates the IP address on the same node, which runs actually virtual machine or the target pod. In case something go wrong, Metal LB can actually detect this outage through the member list and move IP address to the other node.
So we have Metal LB, yes.
We're using Metal LB. There is also other option to use Cilium. It works slightly different. It fully relies on Kubernetes API lists. So it has its own member list, which actually works without accessing Kubernetes API.
Okay, thanks.
All right, then, going once, going twice, and see you in 2 weeks. Bye-bye.
Yeah. Have a nice
Thank you,
time.
Thank
everyone.
you.
Have a good evening.
Bye bye.